Welcome, everybody, to the Seaweed Generation podcast. Today, we have the honour of welcoming Dr. Christopher Pearce, who is a principal marine geoscientist at the UK's National Oceanography Centre. Well, that's a mouthful. Chris's research focuses on the reconstruction of historical global systems which were affected by environmental perturbations and examining how long the planet took to recover from those past climatic events. And then he uses that knowledge, of course, now to investigate potential mechanisms for combating modern climate change through carbon capture and storage and the removal of atmospheric CO2 via enhanced rock weathering and potentially other mechanisms. So welcome, Chris. Thank you so much for joining us today.
Thank you.
So I guess let's get stuck into all of this sort of geological science that you have been doing. So how did you come to be doing this as your full-time gig? What led you to studying the globe?
Yeah, how did I fall into this? Well, I think, like many scientists, you kind of do your studies, and I have a real interest in how the Earth responds to climate change. We know Earth is, not a stable beast. It's constantly varied throughout geological time. There are many ups and downs, and actually, climatically where we are is not at the extremes of that we've seen throughout the geological record. However, what we also know is that the Earth has its systems in place to combat those changes in climate and environments, and it just does this over geological timescales. So what I've increasingly looked at, certainly early on in my research career, is what the implications of those global hothouses had on certain environments, particularly on the oceans, and how we could better understand the mechanisms of those recoveries. And of course, in doing that, we increasingly look to what we're doing as humanity to the global climatic system, how we're forcing that out of equilibrium, and then how can we use those natural processes to help combat where we're increasingly headed. So it became an inherent sort of statement in all my projects and proposals of saying, we're looking at how the Earth system responds to how we can combat that, and then it became an easy pivot to sort of say, well, let's really look at those processes and how we can implement them to help tackle future climate change. So that's kind of how I pivoted into this approach, and that's happened at the same time as many other people have done the same. I think the dialogue has now changed from, is the Earth system changing? Is climate change happening? To, it's changing, it's happening. What are we going to do about it? And really, the questions become about the rates of change. How quickly is climate changing? And we've all seen the IPCC warnings that the changes, the hockey stick diagram of how rapidly these changes are happening. And so the question now has become, how quickly can we enable those feedback systems to kick in and to help us tackle climate change?
So what do you think is going to happen, and what do you think should happen?
What I think is going to happen? Well, it depends on those timeframes. So, geologically speaking, Earth will handle it the way that Earth has handled it. It will kicking the natural feedback systems, enhance weathering, dissolution, to increase rainfall, changes in climatic patterns, increase runoff, increase stimulation of productivity. All these systems, these processes will naturally enable atmospheric CO2 to be regulated. Of course, the reality of that is it takes a long time. The Earth doesn't, its buffering system is built in to be quite slow. It's also really not factored in the scale of where people are and the number of people on the planet and where those people live. So the impacts to humanity, if we don't make any changes, will be immense, because we are living in some of the most vulnerable regions and coastlines and our habitats, and of course our dependence on food and other ecosystems. So we've got to do something because of the situation we've put ourselves in, and we've got ourselves into the situation by bypassing the rate at which Earth naturally releases CO2 to the atmosphere. So we've bypassed that rate. We're on this upwards trajectory still, with increasing fossil fuel usage and CO2 emissions. And so we've got to stop those emissions. We can't carry on as we are. I think that's well established. But in addition to that, we have to proactively remove this excess CO2 that we've already put into the atmosphere. Yeah. So in order to do that, we need to find new approaches that I think stimulate or replicate the natural way in which Earth regulates that CO2. So this could be through mechanisms of increasing the absorption of CO2 through enhanced weathering reactions, so weathering processes on land, which again is one of them systems, or by processes that trap organic carbon in land and terrestrial soils, or by processes that happen in the oceans. We are, as we all know, a blue planet. The oceans cover 70% of the surface, and the oceans are the largest surface reservoir of carbon on land. So we need to look to the oceans and its storage potential for helping to tackle the rate of CO2 absorption.
Right, right. So I mean, obviously we agree with that, but so in terms of where these different approaches are at right now, like where, let's go through the sort of you've mentioned sort of three main ones there. Like where is the research at? What do you think the sort of current potential is, and what do you think that needs to happen for those conversations to move forward? Because there's been lots and lots of chat around the carbon markets, the voluntary carbon market, a lot of projects, especially around forestation and really maintaining forests have turned out not to be quite as effective as they were supposed to be on paper. And that's obviously like a really big theme at the moment. But I mean, I think that we all three of us agree that on a more zoomed out scale, there is the really very real need to be undoing some of the damage that we've done, and indeed kind of maintaining what will continue to be emissions from human activity for some time. So carbon dioxide removal being the sort of umbrella term for anything that removes additional carbon from the atmosphere. Where is the research at for soil carbon mineralization and for ocean approaches at the moment, in your experience?
Yeah, it's a very big question, isn't it? And a lot of people are looking at this. So, I mean, essentially, there were three different core central approaches. I mean, we also referred to sort of soil and weathering processes as kind of land-based approaches. There's also direct air capture, which is kind of more point source capturing, so industrial CO2 emissions. And of course, then there's ocean capture techniques. It's easiest for investors and for humans to sort of work where we live, which is on land. So they've naturally received the greatest attention to date, because we're able to monitor and manipulate the environments around us, and that also has added benefits because of effectiveness, efficiency. If you're capturing CO2 emissions at source, fantastic. We're not emitting in the same way. But then it creates this issue of, well, what we do with the CO2. There are offshore reservoirs, there are alternative products that can be made with the CO2 capture, and people are looking at that as we speak. Of course, that it does require investment, a lot of capital, and it is complicated, and there's lots of other technological aspects to that in terms of actually the process of capturing the CO2, which creates byproducts and things like that, which we still need to understand how to store. The terrestrial-based carbon dioxide removal approaches, so enhanced rock weathering, biochar, peat restoration, and afforestation, things like that. These have all received a lot of attention as potentially novel approaches. We say novel; they've been happening a long time, perhaps just not with the lens of carbon dioxide removal. And I think, as you kind of alluded to, that there are perhaps questions being raised over the permanence. If we're sort of increasing afforestation, well, that's fantastic. It's definitely a plus, particularly from ecosystem and environmental health. But it may not be capturing CO2 on the timeframes that we perhaps need it to in order to tackle climate change, which obviously has to happen over decadal, centennial, millennial timescales. So, some of the other approaches do have their benefits, and enhanced weathering is perhaps one of the longer, more stable approaches towards tackling climate change. And I'm involved in a couple of programs at Leverhulme Centre for Climate Change Mitigation and UK Enhanced Weathering Greenhouse Gas Removal Demonstrator Project, funded by NERC and BUSSC. So there's a different, a couple of projects which are looking at field trials, and really they're giving us the first evidence that applying crushed silicate rocks like basalt to agricultural croplands or other agricultural pastures, highlands, can increase the rate of weathering, because it's finer grained material. You put in environments where there's active ecosystems, they increase the rate of dissolution of those rocks, convert or trap the carbon dioxide in the solutions into bicarbonate, and then that alkalinity ultimately will wash down to river. So we're getting evidence from those field trials that we are producing this alkalinity, we are increasing the rate of weathering, which is fantastic. Of course, the question then becomes over the timescales and the permanence. And this is something that in the longest of our field trials is in 5 years, and we're still sort of trying to see how much of that actually comes out. And these are open scientific questions. It hasn't stopped companies still already pursuing this. There are commercial applications of enhanced rock weathering by some companies such as Undo and Lithos, which are looking at using this approach. It's great to increase our knowledge of the efficacy, but we also need to answer some of the questions about the potential impacts of this. What is the fate of the basalt? How much basalt can be added? Are we going to see potential for particulate runoff if you're doing it on sort of flat surface areas or steep surface areas? And what's the ultimate fate of the alkalinity? When you produce this alkalinity in field environments, that's fantastic. That's what's trapped the CO2. But when it rushes out of the fields, there's potential for that CO2 to be re-emitted back to the atmosphere or, during its passage down to the ocean. So we really need to understand how much of that trapped CO2 actually makes it to the oceans and stays trapped, or how much gets re-released. So there's questions over this this market valuation approach, as well as the environmental health and impacts on sort of surrounding ecosystems. And so that's kind of the two, the direct air capture, then the terrestrial, then that leads us onto the oceans, which is kind of the end of them. The oceans is perhaps the newest frontier when it comes to carbon dioxide removal approaches. Again, a little bit surprising given that it's been the sort of biggest lungs, or one of the biggest lungs for the planet throughout geological timeframes. I guess one of the reasons why we've come to it last is because it's the least accessible environment to us, but also, as humanity, we tend to see the oceans as this sort of pristine environment. It is less accessible. Obviously, near coastlines we interact with more frequently, but the open ocean is less accessible. And so we like to think, we don't want to go and perturb those environments. The reality is they are being perturbed. We know through impacts of obviously fishing, but the export of plastics have really hit the headlines, but also just through environmental climate change. Ocean acidification is having hugely detrimental effects. Marine heat waves, global warming, they affect the oceans in the same way they do on land. So we really need to sort of realize that oceans are changing. There's lots of scientific evidence to support that. So can we, understand the systems that the oceans have in place to deal with changes in carbon dioxide in the atmosphere, and how they respond, and then enhance the rate of those processes. So ocean-based carbon dioxide removal techniques we fall into two categories. There's chemical approaches, which generate basically change the chemical buffering capability of the oceans in the same way that enhanced rock weathering does. You create the alkalinity, increases the absorption of CO2 into the oceans. Then, of course, there's the macroalgae or biological approaches, which is obviously what seaweed generation and other companies are focusing on, which is the stimulation of photosynthesis in the near surface environments to sort of capture the CO2 into organic material. And then you can either repurpose that organic material, take it out on land, use it in different processes, or you can potentially sink it to deeper marine environments where it's out of contact with the surface exchange reservoir. Those techniques are newer in terms of our potential to enhance them. So I think where we're at with ocean CDR right now is we've got a good sense of the processes that happen, but we don't have a good understanding of what the impacts would be if we start to accelerate them to help combat the climate change. So that's really the key area of research that I and colleagues are really looking at right now.
Right. So you, like we, have also been quite interested in the phenomenon of sargassum for us, it's a way of learning about ocean-based CDR and what may happen. And it's also in many ways an Earth response to creating more biomass, which has been created from a lot of the stimulation that humans have been putting into and around the water spaces. So would love to hear a bit more about your work around the sargassum belt and kind of what's going on there.
Yep, absolutely. Yeah. So fortunately enough, I was able to lead a project a good few years ago now called the Commonwealth Marine Economies Programme, which was a UK government bilateral programme supporting overseas developing countries. And through that, I was able to work with countries in the Caribbean region who are, as you sort of alluded to, suffering the consequences of sargassum influxes and have been doing so increasingly since the formation of the Great Atlantic Sargassum Belt in 2011. And essentially, sargassum is this floating seaweed that, since its kind of migration out of the Sargasso Sea, it's kind of become sort of seasonally forms these huge rafts which wash into the Caribbean region, the Gulf of Mexico, and really can cause really very thick inundations on coastal environments. Once it washes up in those nearshore settings, it really it degrades, it gets very smelly, but that smell is, indicative of things like hydrogen sulfide, it's anaerobic degradation. It could be really detrimental to coastal ecosystem health, human health as well, obviously, and it also impacts the countries through the loss of tourism, economically, to cost a lot to clear up. It can be, detrimental because they lost the beaches, people don't want to stay there, they don't like the smell. So it's become a major issue for them. There are ways in which sargassum could be used. People are very innovative and finding lots of projects that can be used from sargassum. But of course, it's from the coming on from the previous conversation about climate change and climate mitigation. There's now a lot of interest in actually potential to stop the sargassum before it kind of washes up in these beaches. So you kind of stop it from hitting the coastal environments, and then potentially get it to capture it and sink it in the deep marine environments, where basically you're having this dual benefit of stopping it washing in, causing those negative impacts on the ecosystems and environmental health, but also helping to capture carbon dioxide by photosynthesis. So today, sort of looking at its potential, we realized that actually it's great. People are developing, including yourselves, developing techniques for actually getting sargassum to sink down to the seafloor, which is part of the problem, because what we really don't know is the deposition of sargassum, what that would do to the deep sea benthic communities. It is a process that happens naturally. So, it does naturally sink. It takes time, it goes down there. So it's completely natural to be found on the deep sea floor. And we've actually seen it on our own expeditions in the region. We've got ROV footage of these sort of rafts of it just accumulating on the sea floor. However, what we don't know is what will happen when you intentionally put more and more sargassum down there. Again, it's this question of rate. So, if you put a little bit down, ecosystems may respond, in kind. They use it as a food source. If you put a lot of it down, then maybe that will overwhelm those ecosystems, or because they're a bigger food source and the population expand exponentially, and that then could have impacts on oxygen consumption. If you've got microbes, they respire, they consume oxygen, you might degrade oxygen conditions, or it could be completely beneficial. It might just give food sources and then stimulate production, and you have more megafauna and more animals living and eating. So we just don't know at the present time what effects it has. And again, part of the reason we don't know is because these environments are hard to get to. So something I've been doing and I'm still seeking to do is to set up the first deep sea thinking trial to look at the effects of sargassum on deep sea communities. And we're doing this in collaboration with Seafields, who are baling sargassum, send it down to the seafloor, and then we can basically keep going to this site again and again over the coming years. Excuse me. So we've got this trial up and running within the EEZ of Barbados, who've been immensely supportive of the approach. We hope to have deposition occurring in a couple of months' time, sort of towards the end of the sargassum season this year, and then we hope to have a few sort of repeat visits over the coming years to see what effect it's having on the communities.
What do you expect to see when you go down a year later for a seaweed bale?
What do I expect to see? I'll be very pleasantly surprised if it's all still there. I think it's the starting point. I think I'm not a benthic ecologist by training. I'm a geochemist, so I look at the CO2 interactions. Benthic ecology is quite new to me. But what I recognize first and foremost is that we have this assumption that deep sea environments are still calm, very deep, very silent. Nothing happens down there. That's not true. There are communities down there. They just operate at a slower rate, so a bit, not as active. So they take a while to respond to things. So we also know there are deep sea currents, particularly on sort of the edges of the islands and in different settings, so that they can perturb and sort of cause removal of products. So I think first and foremost, once the sargassum's been down there for 6 months, when we're due to have our first sort of assessment, if the bales, the sargassum's still sitting there in one piece, then great. I think that'd be a bit of a win, actually. I think just to be able to find it, to see it there, fantastic. It shows that it's not been chewed apart by some passing fish or eel, and it's not been sort of swept away by the currents. Beyond that, I think, assuming that the megafauna and current activity isn't impacting things, then actually the microbes should take longer to respond. The hope is that obviously the carbon is in a less palatable form. It might be pressed, it might be dried, it might be sort of degrade in some way. So doing that should then make it less stimulating, and then the microbes may be less attracted to it. Of course, what could happen is it does act as a food source, as a sort of aggregation through the trophic chain. So if you've got more microbial activity, you've got sort of a greater sort of a higher trophic activity, which then sort of stimulates things going up. Again, those sorts of changes should take several years to enact. So I don't expect that would happen after the first site assessment, which is why we want to keep coming back to the site after a good 3, 4, 5 years. And in fact, Ocean Vision's put out a sort of a research strategy roadmap, which sort of implied that we want to be running these field sites over the 5+ year time frame, just to be able to better understand these type of effects. So that's certainly something we're taking into mind when setting up this experiment, and there is a need for it to keep going back to these sites, and that echoes what we're seeing with the enhanced rock weathering work that I'm involved in. If you take a 1 or 2 year snapshot, then you're not going to get the full picture, so you've got to keep going. And I think the press for us to implement these approaches really needs us to start these small scale controlled trials now, so we get ahead of the game in terms of actually trying to understand what the effects could be.
Right. Yeah, I guess if we're sort of it's currently the beginning or sort of the first quarter just about of 2024 right now. And if we're talking 5 years from now, you're looking at 2029. And there's a lot of pressure, and there's a lot of focus on this sort of like 2030 landmark for global climate change and what is going on there. We don't need to, we don't need to worry about 2030. So we've got 1 year of grace there. What do you think this is going to look like in 5 years' time? Like, you're very much at the cutting edge of what the research is for enhanced rock weathering and the ocean carbon dioxide removal. And we've already talked about how the carbon markets are currently in a pretty interesting place as far as being, I suppose, properly assessed, and people are really looking at this as what it could look like as a climate change mitigation technique. But where do you think we're going to be in 2029?
Well, yeah, in a difficult position potentially. We are not, again, stopping or reducing our fossil fuel emissions. So that needs to have advanced by then. It's hard to see how that's going to happen. Human nature being what it is, we are tied to our current ways of life. So unless there's sort of a major change in policies towards that, then the planet is still going to be heading down one of the more extreme scenarios. Of course, that will then only stimulate more interest in alternative approaches. Renewable energy is going to increase, which is fantastic, but the need for carbon dioxide removal is only going to increase exponentially as time ticks by. And you're absolutely right. When it comes to the end of the decade, there will be a lot of looking around saying, right, what do we need? What can we invest in? What are the best approaches at this point in time? I've already seen in the last few years that the gap between sort of science and policy and commercial uptake has shrunk. The work that we're doing now is directly informing political decision makers' decisions. It's giving them the advice. Sometimes before we can even get the papers published, we kind of do the work and then it comes out and then it's already been uptaken, which is great, because you need to make decisions on the best scientific information. And the knowledge we're getting also needs to inform commercial entities, what approaches are going to work. I do expect, and I think we will see not a panic decision, but a sudden massive ramped up in investment into viable approaches. The question will be, what is viable, what are the effects? And as you alluded to, the trials, even if they take 5 years now, they need to be implemented now, and actually getting us over that battle is a major financial burden. We are not getting investment, certainly here in the UK, but globally, to sort of see these trials start at the rate and intensity that they need to be to give us to enable us to make informed decisions. So I think and hope that that is turning. There is interest in the UK funding system, and there is increasing funding coming from the US and Europe to support these sorts of things. So I think that will increase. I hope that will increase. And then what we need to do is just start those trials and use them to the best of our ability, so that when we're implementing these techniques or looking at what things could be started, they're being done with our eyes open, and also done with the expectation that some might fail. We can't just put all our eggs into one basket. You have to look around. There is going to be no silver bullet. It's a common phrase, but I'm firmly of the perspective that different techniques will work in different environments. The sargassum issues we sort of mentioned doesn't occur globally. Okay, and that's a good thing, but it means that you can't then look to export sargassum into every other nation because you don't want to create the same problem elsewhere. So you kind of use sargassum where it's found, and that may be a part of the solution for the Caribbean region. But then other algae or other approaches might be used elsewhere, and so we kind of got to balance what techniques we're using to fit with the environment and to minimize the environmental impacts, but also to maximize what we're doing to tackle climate change.
Absolutely, well said. So we are almost at our time, but I always finish on the same question, which you may have already partly answered, I think. What gives you, well, we're trying to stay, hopeful, and like we can make a difference and kind of get to the point where we are not boiling the planet. So what gives you hope that we will get there? Assuming you're
I guess I'm a firm believer, again, my geological background, we know that Earth can respond to this. We know that ecosystems can respond to this. They've done it before, they will do it again. I think that in humanity is no longer in the sort of eyes wide shut scenario. We have our eyes open. We're looking for opportunities. We're looking for scenarios. And I think there's a lot of understanding, particularly the new generations. We see the awareness coming through, our children, their children's children, they want to solve this issue. It's not at the top of our agenda just yet. And, human health, human priorities will always take precedent. But I think as we narrow or focus that dialogue to realize that actually climate health equals human health globally, and we become more interconnected, then we can fight to work this out together. Earth has its ways of dealing with it. We've just got to help that, and help that to happen in the right way, and to the benefit of all communities involved. There is quite rightly greater voice being given to the global south, the least developed countries. They will have access to many of the marine environments where this will be done, and much of the Earth's surface area as well. So I think we need to better work with them, to better connect and work collectively to tackle this. And I think we're slow at catching the point, humanity as a whole. I think we've kind of turned that tide, and I am hopeful that over the coming years, whether it's the worst case scenarios would be there'd be sort of more climate change scenarios that sort of push us beyond that point. Hopefully, it won't come to that point, and we will actually realize beforehand, and investment will come through quick enough to enable us to really push forward these changes. But I do think that can happen.
Amazing, well said, and thank you so much. Chris, has been absolutely brilliant talking to you, and we'll be back soon with more amazing guests who are much more knowledgeable than we are about most things. Thanks so much, Chris.
Thanks, Chris.
Thank you for having me. It's a pleasure to chat.
Bye.